Let's go through LeetCode 1047. Remove all adjacent duplicates in string. This question gives us a string S, and let us to remove all of the adjacent duplicates and return the final string after removal. For example, ABBACA. The first step is that when we iterate one by one, we have A and B is duplicate. So we remove this kind of BB from the string, right? And then A, we find that there is A left again, so this will be removed again. And until we have the CA, we do not find a duplicate more. So the result will be a CA, right? So intuitively, we do this question is that we want to use a stack. We put A B push B, and then we push another B. We see pick the previous one, trying to see these are duplicates, right? So we pop this. And then we have another here. We pick here and see this is a same character. We pop this, right? And then we have C and A, right, in a stack. And then we, if we pop, that will be A, C, right? We need to reverse. And so we have the push pop. And we can also, because stack is not is our obsolete data structure, so we can use the deck, right? We can just put from the this kind of direction, right? So let's use this approach to be pretty straightforward. So we are going to have a deck character into it's a new array deck for char C is through char A. Let's say if deck is not empty, right? And deck pick last equals to C. We're going to have the deck remove last, right? As we'll have the deck at the last. You see that. And then we have string builder. SB equals new string builder. While it is not empty. String builder hand that remove first, right? Remove first. We now main return SB to string, right? Last. So we use a deck, and we have three kind of operations. That is add last, remove last, and possibly for pick last. And also after for the rest, just remove first and append to the string builder. But this question, we already use a string builder. We can write something simpler. That is maybe we don't need to use this deck, right? We just use the string builder directly, because we're trying to see whether this character distributor, we create a distributor and trying to see for each character whether the character is the same as distributor's last char. If it is, we just delete the last index. Otherwise, just append to distributor and then return distributor to string. Right? So we don't need the deck even. So let's get a code a bit simpler for this. I think structure will be pretty similar, but we can get a simpler string builder. SB equals new string builder. And what's the for char C S2 char rate. We'll get a string builder size first. In size for string builder dot size. Say if this size is greater than 0, in the string builder the char at size the last character equals to C, right? We just have the string builder delete char at size -1. Otherwise, we'll have just a string builder append. We have else, right? Else string builder append this C, right? Then return string builder dot toString. Right? Length should be length. So this will also be a good approach you're seeing. We don't use a stack or stack, right? It will be very fast because we only use the string builder. We can also use even array, right? Char array use to simplify this. And I think it will be logic will be pretty the same, right? So we'll have a char array. That is, we use a char array to simulate the stack or simulate the deck, right? Array goes as to char array. To char array. And we're going to have this for char C. Char C in array, right? We're going to have an index right here. In index, we are going to have currently there is nothing in it. So we use a -1 instead. So let's say if index greater equals to 0, this index is the the index of the character we put in this array, the last index, right? So if this is greater than equal to 0, and array index equals to 0, right? So this is like a string builder, which compare the last element. Then we just have index minus. Else we're going to remove index one step, right? Just index plus and array index equals 0, right? So this is the same as this. Once we finish this this one, index is pointing to the in this array the last character, right? So we need to return this return new string array the 0 index +1, right? Yeah, you see, this is also fast. Okay. The time complexity will be O(n). for the stream method. And we use a stream builder to skip the deck, or we use a char to simulate the deck. The space, we'll say that is also all in space.